All right, folks, good afternoon. Thanks for joining us today. My name is Rich Sykes. I'm with Amtech. A lot of you on this webinar know me. I'm going to be your host for the next 30 or 40 minutes. The session today should be a pretty good session. We're going to be running a live demo, doing some 3D scanning, followed by 3D printing of the items that we scan. We commonly refer to this as a scan to print application. At the end of the webinar today, we are going to have a question and answer session. We're going to try to limit that to say 5 to 7 minutes. We realize there are probably going to be questions that come up that don't get answered. We realize that, but if you put a question in the chat box while we're going through the webinar and we don't get to it, we will follow up with you afterwards so that we answer everybody's question. Yeah, we'll pose these questions out to our guest speakers as well, because we do have a couple guest speakers. So sit back, let's get this thing going. So I'm going to share my screen real quick, just as an introduction. All right, so a number of you know us. We here at Amtech, we focus specifically on education. We put these products out into the education market. Over the course of time, we run into folks that could use this application, this scan to print application in a number of our customer facilities. Recently, I've done some work with schools such as Harvard, Cornell, Virginia Commonwealth. Hopefully Dr. Means is on the call today. I'll talk about one of his applications here shortly. University of Virginia, and a number of others. And so, you know, there's customers asking us for this, so we thought it might be a good idea to run a short webinar on this and expose folks to it. So where could this sort of thing be useful? One of the applications that we did with Harvard was historical preservation, also the same thing for VCU. It could be a situation where you've got an artifact in your museum. Maybe the artifact is fragile, or it's very, very rare. Maybe it's a fossil or something. It's the only one of them on Earth. You certainly want patrons to be able to touch it and feel it, but they obviously can't touch the real thing. So scanning to print, especially when you have the ability to print something in full color, could be a very easy way to do that. You can put this replica in a student's hand or in a patron's hand, let them hold and see this model. And of course, they've been doing this for a long time, but typically it's done with plaster casts. So in this case, we're going to do it with 3D scanning and 3D printing, which should shrink the timeline down to get these models. We've worked with artists. Folks maybe created a sculpture by hand. Maybe the sculpture was 10 feet tall or something to that effect. You could scan that, you could digitize it, create a scale model the artist could take out, put in front of a potential client, things of that nature. So that'd be another use. And even things like industrial design, product design, we see quite a lot of that. Oftentimes in industrial design, you'll start with a model that was made by hand. This model gets scanned in. Folks talk about it, they change the color, they change the texture, they change angles and so forth till they have a product that they think is good. And at that point, print this out, pass it around the table and have a discussion about it. So these are just a few of the applications and this workflow that we're going to see today, this scanning and 3D printing, the scan to print workflow, just one of the workflows that we can accomplish with what equipment we'll be using here today, such as the 3D scanner and the 3D printer. Another very common application is scan to CAD. We get asked for that quite a lot. I know there's folks on the call today that are from engineering departments, and oftentimes they'll ask about scan to CAD for things like reverse engineering. While we'd love to show you that as well, we're limited to maybe 30 to 40 minutes, so that'd have to wait to another session. If enough people express interest, I'd be happy to run one of those as well. I think Alex would as well, who's sitting over here to my side. Okay, so let's get started. Today, as we go through this live demo, we're going to be looking at a few different pieces of equipment. The first one happens to be the new GoScan Spark from Creaform. This is a handheld scanner that just came out, I think, about a year ago or so. The features of this camera are it's very high accuracy, very high resolution. It does scan in full color. So the items that you see out here on the desk, a number of these are actually 3D printed, but you wouldn't know that because they've been scanned in full color, printed in full color. So this camera is capable of capturing that. It's also handheld, which is nice. It gets you around limitations of something that would sit on a tripod or be mounted to an arm. And it works on a structured light technology, which we'll see in a minute. Basically, that means it casts a pattern of light across the object. As far as Creaform is concerned, this is one of many scanners that they offer. It's their most capable structured light scanner, but they do have a whole range of structured light as well as laser-based scanners. So you'll just see this one today, but there are others. Once we're done with the scanning, we're gonna take a look at how you export the model out of a software called VX Elements, which is the software that drives the scanner. It's also from Creaform. We're gonna output a digital file so that it can be 3D printed and hand that off to an application engineer at Stratasys, and you'll learn about that process as well. The 3D printing that we'll do today, that will be handled by the newest member of the PolyJet family from Stratasys, which is the J55. Those of you that are familiar with Stratasys know they've had a line of PolyJet printers for quite some time. The beauty of this J55 is it's a relatively small footprint. It's office friendly. It runs in full color. They have Pantone matching, so if you need to match a color for a client that's got a specific color, you can do that. Again, high resolution, high accuracy, and probably the most important thing is they've simplified the design so they can maximize the reliability. And those of you that know Stratasys printers will notice that this thing looks quite a lot like their new F-Series printer. So the other cool thing today is we get to see a live demo with our sample part running on the printer. So that's pretty cool. On the webinar today, actually, let me stop sharing my screen here. On the webinar today, we're going to be joined by a few guests, both of which are from Stratasys. The first guest is Mr. Chris Weir, who's one of the application engineers that I work with there. Chris has quite a few years of experience. If you saw I don't know if everybody saw the teaser video where we showed some of the models, but Chris was the one that printed these models out for us. So Chris will be joining us today and give you an overview of the slicing, how he set the model up for printing, and then outputting that to the J55. So Chris, thanks again for joining us today. He's
absolutely happy to be here.
Thank you. And once Chris is finished, we'll also hear from another person from Stratasys, Mr. Jesse Reitenberg, who is the education manager for Stratasys. I've been working with this guy for probably 15 or 16 years. I've lost count, but he'll be running the J55 live from the Stratasys headquarters in Minnesota with our actually the sample of the model that we scanned printing. And then also, I'm told we're going to get a little sneak peek at one of the sort of labs or development areas there for Stratasys, where we can see a number of their printers. So, Jesse, thank you for joining the call today.
Absolutely, Rich. Thank you. Thanks to Alex. Thanks to Amtech. We're excited to show this place off, especially in the pandemic. We're trying to bring it virtually to you because we'd rather see you in person, but we understand.
Thank you, Jesse. All right, so without any further waiting, I'm going to go ahead and share my screen here. We're going to pull up the VX Elements software so that we can do our scanning. I assume everybody can see my screen. I realize some of this video captures pretty quickly, so if it turns out that it's going too quickly and you can't see, if somebody could just hit the chat window. I am monitoring this right now. So if it's going too fast and you can't see it, just stop me and let me know. So I mentioned that the GoScan Spark is a handheld scanner. You're going to watch a quick demo here as I go through. One of the things that I like to point out as I'm scanning these parts is This scanner is very quick, and it also is one of the few scanners on the market that doesn't require any external features for targeting. Now, the scanner can use targets, but it also uses the geometry of the part as well as the color to do the scanning. So you're going to see this. You're going to see this as we go through here. And I'm just going to take a quick sample scan just so that you can see how it works. So I click a button on the side. Hopefully everybody can see that I'm casting a light pattern over the part. Now I am scanning in color. In the world of 3D scanning, we refer to this as texture. You'll notice as I'm scanning, I hope that you can see that there are these sensors on the side of the scanner. I want you to watch in real time as I move too close. This thing's going to tell me that I'm getting too close to the object, or if I'm getting too far away. This is one of the new design features on the Creaform scanners. They give you these visual clues so that you can tell at any time whether you're too far or too close to your object. But basically, the way that I would scan this is just move around the object until I have enough data to represent the model that I have on the screen. So in this case, I didn't get enough. In real life, if I was scanning this for an application, I would most likely be using something like modeling clay or some museum wax or even fixturing, which you could 3D print. And what I did when I scanned this to send off to Chris is I actually fixtured this model in a few different orientations, scanned around it 2 or 3 times, and then I used the software tools to merge these together so that it came out to a finished model. Now, this is actually a hand-carved wooden duck. It doesn't look like it, but this is a hand-carved duck. It was made by a guy that I know who recently passed away. But I want everybody to notice, if you can, and I know it's a fairly wide shot, his initials are carved on the bottom of this duck. And if you look closely enough, you can see that each one of the feathers has a lot of tiny little sort of lines in it that were hand carved to really represent the feathers. And of course, you would get that with this scanner because of the fact that it scans in such high resolution. So I'm gonna switch over just real quick to what the finished scan would look like. Let me bear with me 1 second. This is the scan after I finished going all the way around. And if you look, you can see, just like the actual model, how we were able to pick up all the feature details. And of course, this is because of the quality of the scanner. Now, at the end of the day, not every object will need to be scanned at high resolution, and not every object will have to be scanned in full color, but it does have that capability. So I wanted to point that out. Just a quick note about the Creaform scanners. I know a lot of you are from education institutions. While this is sort of their flagship device for structured light, Creaform makes a number of scanning systems that start under $10,000 and are excellent tools in education because of the fact that they created a curriculum to go along with it. So in this case, we're using a higher end scanner because we want the full color capability, but they have systems that are less expensive that can certainly do the same job minus the color. So once I have this scan of this duck, and again, this could represent anything. It could represent a museum artifact or what have you. What we would need to do now to be able to hand this off to Chris and let him do the work that he needs to do is we need to generate the file. Many of you are accustomed to working with 3D printers. You've exported STLs to the extent that you can do it in your sleep. This is a little bit different now because in this case we've got full color. So the STL file doesn't transmit the color data. That's not part of the file format. So in this case, we need to use something different. We need to use a file format that will transmit the color. And built into the software here, we have a number of tools that will allow us to do that. And I'll talk about those just briefly. So once I have the model that I'm looking for all cleaned up, holes filled and so forth. And this process, if I were scanning the whole thing, probably 10 or 15 minutes worth of work. So we obviously don't have time to do all of this, so I have the one that I've already scanned on the screen, which you can see here. But if you were doing the whole thing from start to finish, you probably have 10 or 15 minutes worth of work, plus maybe 5 minutes to clean up holes or remove some noise. So maybe 20 minutes total to get what you see on the screen, which is still pretty impressive. I mean, if you were to draw that from scratch, it certainly would take a lot more than 20 minutes. So at this point, what I would want to do is export this file. In this case, this is going to give us a bunch of options. We can export the mesh. We can export the color data. In this case, we do want to export the mesh. And I'll just show you some of the file types. In the past, obviously, we've used the STL format. Newer formats, things like VRML and OBJ, would have color data associated with it. But what Chris tells me is preferred is actually a new format, the 3MF, which is your sort of 3D manufacturing format. And it has the color data and also has a good quality compression. So your file sizes are a little bit smaller than some of the older formats like OBJ and VRML. So we would go ahead and give this a file name, export it as a 3MF, and then hand that off to Chris for him to do some of the processing with. So I'm not going to save that. Obviously, I see some questions coming in. We'll get to those at the end. But at this point, it's about 17 minutes past the hour. I'm going to hand it off to Chris. He can pretend that I just sent him the file. I did actually send him the file, but it was a few weeks ago, so he could print these. I'll hand this off to Chris and let him take over from there.
Okay, so we will go from here. I will open up GrabCAD. This is our slicing software. So we'll go through actually how we would process this file before we send it to the printer. So beforehand, we'll actually go ahead and go in and set our printer type. As you can see here, we're going to set that to the J55. From here, we actually want to go in and set our materials. So our default kind of materials are cyan, magenta, yellow, white, and clear. Now the clear or any other component of material can be selected and removed and replaced by another material in the unloaded materials list. Or at the top there, you can get the printer's loaded materials if we're actually directly connected. But right now, we're just working with the template. Since we are remote, we're going to process the file and then send it to Jesse. So we'll save our material types. And then from here, we'll actually go in and add our models. So we'll find that .obj file that Rich sent us. So we can take that .obj, VRMLs, or 3MF. Those are color data files. So the color data is attached to them. So when importing that .obj, we can already see it's already rendered with that full color. We'll go ahead and rescale it, make 8 inches the max dimension. This is going to be a uniform scale, so just hit enter and it should uniformly scale the part. From here, we can see there's 2 errors. One saying that it's outside the build volume, and then the other one saying that there are some model errors, just some mesh errors, some minor errors. So what we'll do first is do an auto arrange. So we'll go into our arrange function and do arrange this tray. Now this is going to arrange this duck on the tray in a position that is going to basically be the shortest amount of print time possible. So this might not be how I want to actually print it, but the arranged tray will just put it on there to make it with the most time or the least amount of time possible. So next we still see we have that fixing error, that mesh error. So we can actually go over into our fixing tab or analysis mode and select repair all models. So if there's any overlapping triangles, any open triangles, the part's not completely water sealed, this will go through and do a quick repair on the model. That way we don't have any printing problems. Now we can see that error is no longer there. And now we are getting close to printing, but one thing I might want to do is print this in glossy mode. So we have a matte and glossy mode, a finish for the part. Now, one way to think about the glossy mode is when you have the finished part, if you have a light shining directly down from it, down onto the part, wherever that light hits, it'll be glossy. So this particular part, if I print it in glossy mode, half of the duck is the right side will be glossy, and then that left side will have a matte finish. So there actually be kind of like a little separation or stair step between those two, the kind of the matte and glossy side. So this isn't really the ideal way to print this. So what I'll go ahead and do is change my orientation, and I'll select that bottom surface and make that the bottom surface for the actual part. And that way, when I print this in glossy mode, you can see that entire top of the part will be glossy. So you have a nice finished part right off the build. From here, I'll adjust it. I'll get it within my tray. That way I'm not outside of my boundaries. Looks good. And then I'll run my estimation. So our estimation will show us our print time, our total model and total support, and then it will give us an actual breakdown of the individual model materials that are being used at what quantities. At this point, we can go ahead and go in and save it. So we can do file and we'll save it as a project. Now this will be a .print file. So I can send this .print file over to Jesse in front of the printer, and he can load this up into his software connected to the printer, and this will have all the modifications that I've made to this part file ready to go. That way I don't have to communicate to him. I need to have it rotate in this direction, set to glossy. It's already set up. I just send him the .print file. So it's easy for him just to grab it and load it up. Now I can also go in and override the color data. So I can say, okay, well, I want this part to be a pure cyan part. Or maybe I can go into my color picker and specify a specific color. It can be RGB, it can be hex. And you can as well change that alpha value, the transparency. So an alpha value of 1 would be completely opaque. An alpha value of 0 is completely transparent. So just some additional modifications you can do to override as well. Now, talking a little farther, we're talking, that was a .obj. Now we can look at VRMLs as well. Components of VRMLs is a .wrl file and a .png. Those are the two components, two files that make up an actual VRML file. Now that .png is the actual texture data or that color data that is assigned to that part or that WRL. Now the cool thing about this is we can take that .png into a program like Photoshop, and then we can modify that texture. Say here, I'll take a brush and partially delete or make it partially get rid of some of that opaqueness, make it partially transparent, and I'll save that over the existing PNG. Now GrabCAD sees empty pixels like this as clear material. So now if I save this in and I load it back up and maybe I make another little modification to that duck file, we'll see what can happen, because now it's not completely opaque file, PNG file that GrabCAD is getting. It has empty pixels in it. So it's going to change how GrabCAD actually processes that part. We'll see once we load it up here. So we'll do, we'll change the scale again, do the max dimension at 8 inches. Get it oriented in the correct way. And we'll get it back here on the tray. And so what you can kind of see already is that duck is now partially transparent. So since I made that PNG partially transparent and I saved it over its original PNG file assigned to this VRML, it now makes that entire duck partially transparent. And now I took I made an amazing 3D file and I embedded it inside this duck just to show you the additional capability. So now I've taken that scanned in duck, I've made it partially transparent, and I've put another file inside of it. Just to give you an idea of kind of where you can go and what you can do with some of these files. So there are advantages and disadvantages with the different 3D files, the .objs, the VRMLs, and the 3MF. It's all really dependent on your native software, on what you're using. Some softwares might be easier to edit, like in Photoshop. I can take that .png and modify it, whereas it's not quite the same with a .obj. So it just kind of goes beyond that a little bit. But from there, I would take that .print and I would send it over to Jesse. So I will pass it over to Jesse here at this point.
Chris, just real quick before you move on, I noticed on the J55 you got the round build platform as opposed to what we're accustomed to with the F-series machines and so forth. I mean, I noticed that. I'm assuming there's a reason that's round, or is that something Jesse's going to cover?
Round, right? So yeah, that's probably something Jesse can touch on as well. But right, we're no longer actually translating our heads in the X and Y motion. Now our heads are kind of sitting still, and that tray is revolving. So
Very
it's
good.
kind of reinvented printing because now that tray is constantly revolving, so we can actually have a lot faster printing that way because we're now not moving our print head around in the XY axes. It's sitting still and the tray is constantly revolving.
Okay.
Changing acceleration, we're keeping constant velocity.
Okay. Thank you.
Rich, are you ready?
I'm ready, man. What do you got?
All right, I'm gonna flip my screen. Hopefully everybody can see. Hopefully everybody can hear. As I at the office we do have to wear masks. But I'm in the Stratasys headquarters in Eden Prairie, Minnesota. Beautiful location. Even the weather is beautiful today. Good, nice 50 degrees, which is rare for us in November. But this is our customer experience center where we can actually engage with customers in an area that it's not roped off ITAR or restricted access. So we have a lot of tours that come in here and we get to showcase all of our technology. As Chris mentioned, one of our revolutionary product, pun intended, is spinning right in front of us. The round table and the turntable, like Chris said, it makes for what we're seeing is a more consistent product. Reliability has gone way up due to this process. As you see here, our duct file, we have been printing. This is staged a bit, but this is really printing. The file that was sent over, printing right there. You can see up in the head that the head is an LED light, so it's got a longer longevity than our standard UV. And then underneath is where we hold our materials. This is our first printer that we're selling under $100,000 that can print multiple materials. You can see 6 bays here, 5 material and 1 support. And you're actually seeing a system that's printing with our ultra clear, which is under beta test. Nice compact body. And then I'll show you another little component to this is we have a filter. So we have a filtration process that there's no venting necessary out of a building or a facility, as we have a standalone Pro Aero filter. The parts that come off this, pretty impressive. We can get, like Chris was showing, some clarity with colors inside. We can get mixture of colors to represent different things. We've built lenses. We've built bones. We're keen on the Hollywood folks. So if you've seen the movies, Kubo and the 2 strings, the Leica characters, even the missing link now is from that. So we can do a lot of different capabilities. And Stratasys just doesn't print the color parts. We also create parts that are being used on race cars, end-use products like the One Wheel. Very, very diverse capabilities. Here are some of our cool models that we've been creating for a group at a university in Texas. So high fidelity models showing color, showing capabilities. So a lot of things we can do here. And then, like I said, we're at the facility here. This is one of our facilities that has 25 or 30 printers. We set up as PolyJet on one side. We've got our digital anatomies. We've got our J50s materials, nice and clean. And then we have our FDM. So an exciting facility. We love touring people around, but it's kind of been reduced to what we can do for the time being. So hopefully this virtual tour was exciting. One of the questions I saw in the chat was, what is the resolution that the J55 is depositing at that? We're depositing droplets of material at about 18.75 microns per layer. And that equates to about a 300 by 300 dots per inch. But very high quality parts and we have many people that something off of a $400,000 J850 versus a J55. They're not able to typically see the difference. But then also parts like this, we can sand, paint, plate, and clear coat for better clarity. So,
Impressive.
Rich, anything else you want me to touch on?
No, I mean, I think, you know, for our purposes, that's what we wanted to cover today. I think, hang on, somebody just threw a question out there to you. Well, let's go ahead and conclude the demo part, and we'll get into a bit of Q&A if that's okay. And I'll have you guys answer the stuff that you can answer. I'll answer the stuff that I can answer, and so forth, if that's okay.
I think that's A-okay.
Awesome. Well, I'll go ahead and let me put up my Q&A screen here. Bear with me one second. Whoops. Hopefully this is not showing up. Awesome. Okay. So, but thank you both, Chris, Jesse. I appreciate it. You know, you guys helped me tremendously to pull this together. The stuff you mailed out and getting the stuff printed, I greatly appreciate it, and I greatly appreciate your comments here today. So, at this point, it's about 33 minutes past the hour. I'm going to take some questions. As I said in the beginning, we might not get to your question. We may. I apologize if we don't, because we don't want this to run past about 40 minutes. So that's kind of our hard stop. If we don't get to your question, somebody will follow up with you after the demo's over, and we'll make sure that we cover those things that you're asking about. So I did see a question come in just a second ago. The question came in about J55 being full color and whether or not it can print with clear materials. Jesse or Chris, do you want to take that?
Yeah, I can jump on that. Absolutely. I showed the makeup of what is in the system now, and we had our Vero Ultra Clear. We have models similar to this. And as Chris showed, you can even do a kind of a clear exterior around even the duck when he shared his amazing file transformation. So yes, absolutely. Clear. And we actually have future materials to come out on these printers that will be coming out in 2021. So we see it as a product just like our F series that we're launching, and we're just going to continue to add value to.
Okay, great. Thank you. Another question came in, you know, it says here, Jesse, you talked about, have you talked about what to do with the support when the print is done? Obviously, if you guys saw the print going around there, support material was on the outside. So I guess the question relates to what happens with that support material. Do you chip it off? What do you do?
So when this part comes off the printer, when the duck is finished, what we'll do is we'll take it over to one of our water jets and think of a dental pick. But basically, we put the part in there and we spray off the support. It's a very simple, and as my young daughters say, it's a very satisfying feeling when you're spraying support off of a model. But currently, it's a sprayed support, and we are working on water soluble.
Awesome. Thank you. Somebody, I guess this is one of our users out there, asked, I guess they're accustomed to using GrabCAD. Can GrabCAD process files on their F series machine as well as with the J55? Jesse, Chris?
I'll take that one. So it can definitely process any files for any system, basically any Stratasys system, FDM or PolyJet that is newer. Some legacy systems might not be on there, say like a Dimension 1200. I'm not sure if that's on GrabCAD anymore. But any modern system right now, any J series and F series, you can certainly switch between. When I first started my video, I was selecting an F900, so a 900, a very large format FDM printer. So then I can just basically go over to a different printer's template. Again, I don't have to be connected to the printer. I can select basically any Stratasys printer's template and process in that. So you can definitely jump between systems.
Okay, thank you, Chris. We had another question here related to the scanner being compatible with software such as Geomagic and so forth from my buddy Ron. Yeah, absolutely. I mean, the files that we're generating from this scanner are pretty much compatible with any 3D application, Geomagic being one of them. You know, the VX stuff, Polyworks. I mean, there's a ton of applications out there that people use that are paid applications, as well as you know, Mesh Mixer and things of this nature, which you can get for free. So these files have no issue working in those environments whatsoever. A lot of people like Geomagic Wrap because it's a very conversational tool. But I would say, generally speaking, especially for those of you that are coming from education, Creaform does a great job where they offer a 50 user license of all their of every software tool they make at no charge with the price of the scanner. So even that $10,000 and under scanner has 50 seats of software, and you'll find now that the tools are as I like to say, they're up to 21st century. They've revised them so much that they're almost as good as having a seat of Geomagic. So rather than paying a couple $1,000s for a commercial license of Geomagic, you may very well be comfortable with what comes with the scanner, and certainly we can train you and get you up to speed on that. So Ron, you might not actually need Geomagic, but the answer is yes, you could use it. Thank you. Let's see here. We had somebody ask about whether or not they could use this in a high school program. In a nutshell, yes. You know, there's no problem using this really at any level. I would say high school and above. I don't know that I would sell necessarily the Cadillac into a high school program. You might not appreciate the advanced features in some of these super high-end systems, but a system like the Spark or the Academia series, there's a full curriculum around these tools. They also have in education, they give you a 5-year maintenance contract when you buy the system. So all your software updates and so forth are free. And there's a reduction in price for education. So it's actually a pretty compelling setup for high school age kids, especially if you've already got some of these technologies in your lab, 3D printers and machine tools and things of that nature. So yeah, it absolutely could be used. What's our time? We got about a minute left. I'll grab one more question. And again, I apologize if we don't get to you. I see a ton of questions coming in. I know we can't get to them all, but we're going to take one more and then conclude for the day. But we will follow up. And again, I apologize. Trying to keep this right at about 40 minutes. So Hector had a good question here related to additional post-processing. And Jesse, you kind of touched on that a little bit with the sanding and so forth. Could you comment on that?
Yeah, absolutely. To me, it's all about what your end part wants to look like and how much time and effort you want to put in. We post-process constantly. We're sanding, we're painting, we're plating, we use a lot of clear coat. We use something that's called a photo bleacher to make some of these parts clearer. But the beautiful part is we have the experts doing it. We teach people all the time. So any type of post-processing that you want to do, we can showcase how that gets done. Some of it takes more time. If you're doing a more organic shape versus something flat, it may take a little. But we're always practicing. We're always trying new things. The latest things we're doing back there is a dip where you're just doing a quick dip and letting it dry. And then I see Hector also asked about using removing supports without a water jet. Yeah, absolutely you can. It makes it a little more laborious, but you can pick off anything you want when it comes to those polyjet parts.
Thank you.
Yeah,
Jeff.
just an additional note to that. That's removing supports is about the only post-process that's actually required. So polyjet isn't like SLA technology where once the part is done, you have to put it in an additional chamber. The part's already cured and ready to go. So.
Thank you, Chris. Yeah, guys, I just saw this chat. Sorry for having my chat window or my question window up in front of my screen there for a moment. I apologize for that. I'm a bit of a novice at this, so you know, it happens. But yeah. All right, so we're now at 40 minutes past the hour, 41 minutes past the hour. I'll have to stop with the questions right now, but I would like to, before we leave, just thank everyone who attended. A very special thanks to our guests, Jesse and Chris, for sharing their information, their best practices, and their time with us today. We couldn't have done it without you. And Chris, I mean, the models you sent over were fantastic. I do greatly appreciate that. So with that, that's going to conclude our webinar. Hope everybody has a great rest of their afternoon, and hope to see you guys back on one of these in the not too distant future. Thank you all.